Okay, good morning. Welcome to
Remember 1111.
1111. So today we're going to do a series, I think, of 6 really quick looks at some graph networks. So have you ever heard of this referred to as a graph?
Yeah.
Yeah, you have? Have you?
Yeah.
Okay. And what we're going to do is we're going to look at how, like, the simplest possible model of how a virus would spread through these different kinds of networks. So we can think of each point on the grid as being a person, and then the lines being the connections that they have.
Okay.
So on this grid, how many connections does a person have mostly?
4.
Yeah.
All your neighbors, except if you're on the edge or corner.
Yeah. And so we see with this one I made, it has on average about 3.87 connections.
Yeah.
So which isn't too hard to believe. And then we actually can look really carefully. If we infect one person here down in the bottom corner after 4 steps, step 0 is the infection after 4 steps. If that person infects everyone they touch, and then everyone they touch infects everyone, the infection looks like this in red. So hopefully that shows up on the video. So what do you think is going to happen as time progresses with the infection in this graph?
The graph will just slowly turn red in layers. Everybody will get infected in sort of layers because it can only spread through these contacts, and then eventually everyone will get infected unless, like, at some point people become uninfected.
No, in this case we're just assuming once you're infected, this is just the simplest model you can imagine.
Okay.
Simple infection. Once you're infected, and that's it.
And since everybody has contact with a lot of people, then everyone will get infected.
Okay, do you think the spread through the network here will be quick, or will it take a while?
It should be pretty quick. I mean, you're infecting more and more people with every step. I mean, until you get to like this, like directly opposite this, somewhere up here. But
Okay.
you keep infecting a lot of people, so it shouldn't take too long for everyone to become red.
Okay, so here's the number of people infected at every step. So 1, then 3, 6, 7. Like that, eventually 66. That's at step number 10.
Okay.
Again, step 0 is when the first person's infected. And there's a graph of it. Well, there's our little short table. There's the graph, and there's a log plot of it too. So what do you think about the infections here?
It's pretty exponential, I would say. Like it's getting exponentially more.
Yeah, well, if it's exponential on a log graph, it'll look like a straight line. So
I
since
think
it's
it's slightly less.
Since it's bending down, it's a little bit below exponential, but we're not full yet after 10 steps. So why don't you take a guess as to how many steps it might take? You can look at it up here.
Maybe 40 steps.
All right.
We're still not there yet.
Yeah.
I guess it's the infection rate. Once it reaches this corner, it's going to slow down again.
Yeah, so let's look after 70, you're fully infected, and then we
Okay.
can look at it down here on our charts. And let's see.
Yeah, so it sort of curves off.
It's even before 70. So how would you describe this infection progression?
It seems like the infection rate sort of grows at the beginning, but then in the middle here, it sort of resembles a straight line because of the
And
way
this
the
is the linear plot, and the log plot is down here. Just to be clear, that's the log plot. So this is the linear plot. So on a linear plot, when it resembles a straight line, it just means that the number of people is growing the same every step.
Yeah,
like a
it's
line.
probably because how the graph is formatted. You just
Okay.
get the same number of people every time, and then eventually it sort of tapers off.
All right, but it took a while for the infection to spread through this network.
Yeah, it did.
It did. And our average connections on this network were
3.85.
Yeah, about it's right around 4. Okay, so the next thing we're going to do is just take a look. The next ones will be more quickly. We're going to take a look at some different kinds of graphs.
Okay.
Right.